Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 69th CoCoRaHS Weather Talk webinar. A very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live here on this last day of April on what could be a rather toasty day here in Fort Collins, Colorado. For all of you who are unable to join us for our live broadcast, we are recording today's talk, and it will be available later this week on our website. All of our CoCoRaHS Weather Talk webinars are sponsored from generous donations by listeners just like you. Well, today's webinar is on NOAA's Weather Prediction Center. Perhaps you've heard of it. This is the first webinar. There'll be two parts to this. There'll be another one in December talking about winter weather. But today we'll look at QPF, and what is that, you may ask? We'll also take a deep dive into heavy rainfall products. With us today is meteorologist Greg Galena. He's a longtime friend of CoCoRaHS. Greg works the MetWatch desk at the WPC, where he focuses on heavy rainfall. Greg is also Maryland's CoCoRaHS Anne Arundel County coordinator, and he's held that role for quite some time. We're very thankful for him in doing that. He's a Cincinnati native who has had some early encounters with severe weather during the 1970s, which he'll tell you more about in a bit, and he's been interested in weather ever since then. Greg holds degrees from Valparaiso University and also the University of Wisconsin. He began his tenure at the WPC in 2015. Greg loves maps and all forms of satellite analysis, and that's not just limited to weather. He's credited with discovering two comets. How about that? Back in 2004 and 2005. And he also has an interest in volcanoes. Greg lives in Maryland with his wife, two young children, and his dog named Denali. He says yard work, planting, and planning is a great stress reliever, which I'm sure we could all use a little bit of these days. Well, let's give a warm welcome to today's presenter, our friend, Greg Galena. Greg, it's great to have you with us.
Thank you, Henry. It's a pleasure to be here.
Hey, I'm going to start off with two quick questions for you. So volcanoes, and I traveled to Iceland back a couple of years ago, but I still cannot pronounce the name of the famous volcano. Could that roll off your tongue for us?
Yeah, back in 2010, I actually worked at the Volcanic Ash Advisory Center, so I had to give a lot of talks on the radio. So it's Eyjafjallajökull. That again is E15 for all you military folks. They didn't even want to pronounce it. So again, Eyjafjallajökull, but again, that's actually the name of the ice sheet, not even the name of the volcano.
Wow, how about that? Hey, so I alluded to the second question earlier, 1970s Ohio. So yeah, the super outbreak in 74. Tell us a little bit about how these events affected you and started your interest in weather.
So I was born in 1977. So you sit there and say, well, 1974, that's the super outbreak. What's the deal with that? And the simple answer to that is that my mother was around for that. And she, in fact, my cousin was born on April 4th, 1974 in Cincinnati. My aunt could see the tornado from the window of the hospital as she's giving birth. So my family is a little bit more attuned to this. And so my mother became nervous about it. And in October of 1977, a tornado touched down very close to my house, and at 4 o'clock in the morning. And since then, my mother was very attuned to the weather. So I started paying attention to the weather, and I was afraid of it. And so I would collect everything up, and it just became a fascination, watching the Weather Channel and getting way into it. So here I am today.
Wow, that's pretty interesting. You know, I think a lot of us in the meteorological field and climatological field have similar stories of events in our younger lives that have brought us into this field. So, well, thanks for sharing that. Hey, Greg, I'm gonna hand it over to you now, and we'll come back in a little bit, and we'll take some questions. And folks, you're in for I saw a preview here earlier. This is going to be a really great talk. So. We're recording it. If you're not here live right now, you'll get to view it later. Okay, Greg, take it away.
Thanks, Henry. And once again, you can see I've got my cursor here, so I'll be moving back and forth on here if I want to point something out. But That's a terrible picture of me in my hockey jerseys that I like to wear on my midnight shifts right there working at the surface desk at WPC. So when originally I was approached by Henry and the CoCoRaHS team, as well as my management, to give this talk, and I thought, sure, let's do this, no problem. I mean, this is perfect. I mean, we're a perfect match for CoCoRaHS. I mean, rain, snow, okay, the hail's over at the Storm Prediction Center, but those are some of the core elements of WPC. So I said, sure, let's talk about this. And I need to give you some background on what we're actually doing before I really want to get into the topic of the heavy rainfall. And I thought to myself, this is going to be really huge, especially with that winter weather in there. And of course, winter weather is kind of ending right now. So why don't I split that out? And so here we have part two is going to be given by my colleague, Josh Weiss. He'll be doing that in December, probably towards the peak of the winter weather. Now, of course, that's not the name of the talk. I like to add a little bit of humor to my slides. But he will add a new topic and it'll get uploaded. And so you can sign up for that one after you hear about WPC, what its role is, and then the heavy rainfall, because we're getting into the heavy rainfall focus season. So with that, the scope of this talk, I put quick in overview because WPC is a pretty big organization. It's actually one of the larger national centers. And I'll touch base with that in a little bit here. So I'm sitting there, how do I break this up and not talk too much and too long? So that's why we're breaking it up into two pieces. So we go, I might move through some of these slides pretty fast, but it is recorded, so you can always go back, pause recording, take a slide link, and digest it more of it. And like Henry said, I will have an email for you at the end of so you can always ask more questions later on. So with that, let's move on to some history here. So give you some historical roots. I mean, going back to the founding of even the Weather Bureau. I mean, so WPC itself is rooted in the Analysis Center and was referred to as the Forecast Operations Branch. This is still what we actually call the operational portion of WPC is the Forecast Operations Branch. But that was created in 1942 and was located with the Weather Bureau down in downtown Washington, D.C. And again, you can see that they were producing forecast and analysis products in the short-term period from days 1, and even some climatological forecasts out at day 3. But even further back, you can actually trace roots of things that WPC does as far back as 1871 in doing the surface analysis, taking surface observations from all around the country through the telecommunication system of the time, you know, through teletype and everything like that, and then they would create maps and surface products. And so you can even see the archive of this from WPC's page if you hunt and peck for it. In 1958, WPC and this forecast and analysis group merged with the fledgling groups of computer technology, where they joined with the Joint Numerical Weather Prediction Unit, and they moved from Washington, D.C. out to the Suitland campus in southeast of D.C. in Maryland. And that's actually where they merged with this group, and they became named the National Meteorological Center, or NMC. And they were located into the Federal Operations Building, or FOB4. So it's kind of interesting that WPC's FOB was located in FOB4. But again, it's located in the Suitland location, and we've since moved in time. But in 1966, this joint group of NMC was able to produce the first weather model output in 1966. In 1970, the Weather Bureau became the National Weather Service, with NOAA created, over-enveloping to the Weather Service as a whole. So the National Weather Service is just one branch of NOAA as a whole. And in 1975, WPC, as well as the rest of NMC, moved from the World Weather Building in Suitland just down the road to the World Weather Building in Camp Springs, Maryland. And then NMC transitioned in 1995 and was renamed the National Centers for Environmental Prediction, or NCEP. So you'll hear a lot of these acronyms. You know, we do love to produce acronyms within the Weather Service. And with that, WPC was formed as the Hydrometeorological Prediction Center. So FOP was tucked into this group called the Hydrometeorological Prediction Center. So hydrometeorological is too much of a big word, and we'll talk about that in a second. But it also includes some of these other acronym soup of the Storm Prediction Center, Aviation Weather Center, and we'll talk about them in a second as well. So here's our new beautiful building. Here's our old building at the World Weather Building, which was also called the National Science Center. And we moved from the World Weather Building in 2012, and we're co-located or very closely located to the University of Maryland. We're actually on an east extension called M Square. So you see this nice, beautiful building. WPC is actually located on the 4th floor of this building on the other side, and so it's really, really nice. We can see, deer and other wildlife, and we actually can watch weather produced to our north through these beautiful panoramic windows. So it's a big upgrade from this old building. And quickly after moving from this new building, which is called the NOAA's NOAA Center for Weather and Climate Prediction, NCWCP, HPC, or the Hydrometeorological Prediction Center, was renamed the Weather Prediction Center, or WPC. That fits in really well with the name of the building, especially considering that the Climate Prediction Center is also co-located with us. But again, just recently, we've lost our friend in the World Weather Building. Oops, excuse me. It was recently destroyed in 2012. Now, there are some people that I work with in this old building that might shed a tear. Most people don't. So it was actually kind of a really nice upgrade considering all the wonderful things that we have at our new building. But if you do happen to live in the DC area or in the DC area and it just happened to be around, we do have formal open houses, typically once a year. Unfortunately, with the COVID situation, we probably won't have one this year, but you're welcome to come in and visit us and take a tour of the building and see exactly what else is going on in the building. And as I pointed out, the National Centers of Environmental Prediction is really, really vast, and it's a large organization of these national centers, as obviously it says in the name. And most of those are located actually in the building. And you'll see here anything that's surrounded by yellow are places that are located. But also we have other sister organizations that exist on the outside. And so the NCEP is hubbed in this building. And so we have a central organization, central operations organization. It's one of the 9 branches of NCEP that runs the computer models, that run administration, IT, the management group. So they're also located in this building, but here are the rest of the other 8 groups that are located in NCEP as a whole. Give me 1 second. There was a little technical difficulty. There we go, we're good. So you see, we have the Aviation Weather Center. They were created in 1995 when NCEP was created, and they were actually branched out of WPC, or what was called the FOB at that time. Very similarly, OPC, which is actually located in our building, they were also in the same way. That's the Ocean Prediction Center. You have the Storm Prediction Center. They were moved from Kansas City as the severe environmental storms, or let me see, what was that? That was the severe local storms unit. So SE for severe, local L, and S for storms. So cells, and they were moved from Kansas City to Norman, Oklahoma in 1995. And so what ended up happening is AWC flew right into their building and took their space. This Climate Prediction Center was, like I said, part of that larger FOB, and they were split out to basically take care of the forecast periods from longer than 7 days, and they still exist within our building. And then you have the National Hurricane Center, which was part of the forecast office branch in Miami, Florida. So their role grew and became part of NCEP. And then we also have the Space Weather Prediction Center, which was created in 2000. Well, it existed before, but it actually was joined NCEP in 2005, and they're in Boulder, Colorado. And they forecast space weather, which is very important for satellites and telecommunication disruptions. So what is the National Center? What is it goal? What is its role? So what do I mean by this, the statement of providing specialized overview of daily national level expertise? WPC and other national centers experience their hazard on a daily basis. While certain local forecast offices may only experience the event once a week, maybe even once a season, even just as short as once a season. Some offices see that something very frequently. So you have Oklahoma, a lot of tornadoes. You see Texas and Louisiana, you see a lot of flash flooding. So they have a lot of experience. So this doesn't discredit the local forecast office, but they don't always see it as often. So you need sometimes to have a specialist. So if you liken this to an analogy of a general practitioner doctor versus a specialist, the National Center will act as that specialist and deal with those specialized events that they see more frequently. Basically on the daily event across the nation, they see how the computer models and everything change and deal with that. So those expertises then feed down and provide service to forecast office. As the local forecast office is actually responsible for any of the products that you were to get. So any of the warnings, any of those watches, any of the discussions, any of the products that are coming out with how much rain is going to be, what's their temperature going to be. And that is responsibility-wise at the local level. And so they're directly communicating with you as the public. They're directly communicating with their local partners and FEMA and other groups, such as emergency managers. But so our goal as the National Center is to assist them, technically reduce their burden. At least that's what we're trying to do with providing that national experience where we see everything on the routine basis. And of course, they're going to feed back to us. So there's a nice up and down motion to this collaboration to get you, the public, safe for protection of life and property. And I like to use a quote that I have from a colleague. We like to make a difference in the lives of those who make a difference. And so that I think looks at the way a national center looks towards a local forecast site. They're the one making the precise difference with the warnings, but we'd like to say we're making a difference in the way that they're doing their role. So WPC is a little different than all those other national centers I showed you before, is that it is the parent organization. So its mission is a little bit broader. So we have more of a broad scale. And so we have experience with things such as model preference, knowing how a model works and how it's connected, and, if you will, the preferences of which model is going to work better and which ones are not going to work better. Some of the less sexy, weather hazards or threats, say not like tornadoes or hurricanes, but still very important: heavy rainfall, winter weather. Those are things that we've actually built some quite good experience over the last year. And then, of course, the fundamental pressures and fronts. I mean, so all the daily weather maps that you've seen basically since FOB was created and before in 1870, those pressure and fronts are generated at the National Weather Service, or I'm sorry, at the Weather Prediction Center. And then, so it'd be much easier to have a nice overview of those pressures fronts instead of having each forecast office try to exactly line up with each other. So I was talking to you before, it's like we were called the HPC, the Hydrometeorological Prediction Center. So we have a bigger scope than just hydrometeorology, which is, of course, a confusing term. So we did change our name to the Weather Prediction Center. So even though all the other centers are predicting weather, we are the Weather Prediction Center. And so WPC itself, and in particular FOB, has 9 specialized desks that are staffed 24/7. Let me take that back a step. Is that we have 9 specialized desks that are staffed at least one time a day. Sometimes we have as many as 9. Sometimes it's as few as 7 on at a given time. And then we also have our sister organization, or our development branch, that runs the international desks. They have developers, as well as we have responsibility for providing backup to the National Hurricane Center if it were to go down. WPC FOB branch has a total of 32 forecasters, a branch chief who is Greg Carbon, who's been on these talks and series for quite a few years, as well as a med tech. We have one of the last med techs within the Weather Service, a gentleman that's over 70 years old who does a lot of our overnight charts. And then we also have a new warning coordination meteorologist, so we have some similar terms of the local forecast office. Then within our sister branch, we also have a science operation officer, a SU, and numerous contractors. So in total, we have 59 staff members, even though we are currently down 2 vacancies at our surface desk. And then, of course, we have administration and bosses above that, such as Dr. Dave Novak and Kathy Gilbert, who's our deputy director, who organizes and runs and interconnects with the rest of the NCEP group. So this makes WPC the largest of the national centers, with the exception of the Environmental Modeling Center, as well as that NCO, National Center of Operations. Both of those are more support driven. They manage the computer systems, they intercommunicate, making sure all of the communications between the national centers to the forecast offices are working, as well as making sure with ENC, making sure the computer models are up to date with the newest science and keeping those running with a bunch of science. And you can see, with having such a big group, with such a large, vast thing, you can understand why this talk is going to probably be a little long. So let me go on to our domain of products that are done in the weather prediction. Now, the WPC and the bulk of its products are driven here in the CONUS. So you can see the red outline here. And so we do have a large sense of responsibility, though, because we also have responsibility to write medium range discussions and grids for Alaska, as well as a discussion for Hawaii. And then again, I was talking about that international desk of products, and it's not a 24/7 group, but you can see the domain that they capture. And then this green box indicates any of the places where we actually provide rainfall statements for any of the the National Hurricane Center or the Central Pacific Hurricane Center's hurricane forecast if they were to impact land. So we're going to provide a heavy rainfall state to them if it is needed. So moving on to the international desk, this is a very underlooked portion of WPC's mission, but a very cool portion of our mission, where we outreach to Caribbean and Latin American weather colleagues. And so we have visitors from these countries and their meteorological organizations come up and sit with 2 professional training forecasters, Mike Davison and Jose Galvez. And they do a lot of interaction while producing forecast charts like you see here with the forecast bulletin, QPF forecasts for Puerto Rico, QPF charts for other locations within the Caribbean and South America, as well as some analysis of the surface maps, and then QPF charts in the longer range for South America as well. So these people come together, they produce products, but at the same time, they're learning techniques and methods that we have capable to us, and then they take it back to their local forecast governmental agencies within their countries and expand. So it's a really nice interaction where we're actually collaborating with them on a regular basis. So, but let's go into, and unfortunately that is only run, during day hours, Monday through Friday. And these people, and this was started in 1988, and these visitors generally only come for 4 months and then they go back. So let's go into the bulk of WPC's mission. And this is as I said, we have a really long talk here with a lot of pieces, a lot of products that are being produced, both with a man-human interaction as well as automated products. And a lot of these will be visible on our page. But I'd like to break this down into kind of 3 different mission areas where we are providing that national situational awareness and readiness for hazard weathers. And a lot of these are on a routine basis where basically every single day the product gets produced, it's out, and it's on the webpage at that same given time with particular deadlines. So we have gotten a few new products that are event-driven, which we'll touch base with. So first, I'd like to talk about the analysis portion of it. That surface analysis that we've been doing since 1870 is produced A portion of it is produced at WPC, but is unified with other organizations that are doing that. And we'll talk about that in another slide, as well as what is the national high-low? I mean, what's the highest, coldest temperature within the United States CONUS within the last 24 hours? That's produced here at WPC. So if you ever saw that within USA Today or some tweets or some things on your local TV broadcast, that's where it comes from. And then some other larger scale looping products of grabbing all the products that are produced within NCEPT and bringing it into this day 1 through 3 hazard. And I'll show you that in a bit too. The bulk of our forecasting and the bulk of our products are produced in the short range. So we have 5 forecast tests that are in this things, and this is where the short-term fronts and pressures are produced. And again, this is what I mean by short-term in this aspect is that the forecast is from 6 hours to 84 hours. So it's really kind of day 1 to day 3.5. But pressures and fronts actually are produced in a shorter range. The QPF here, which drives the winter weather, is done, all the way out to 84 hours. There's an excessive rainfall outlook, which we're going to talk about in a deeper dive. This Met Watch, which is what Henry was asking about, what is Met Watch? This is where we do a mesoscale precipitation discussion. So it's even shorter than 6 hours. It's actually 1 to 6 hours. It's more of an analysis of what's going to happen in the short term, where heavy rainfall is going to occur and potentially flash flooding. And then we're also taking numerous national media phone calls. So it's getting reduced here with the recent virus. They're not as interested in the weather right now. But we do take a lot of media phone calls, particularly with heavy snowfall and rainfall. But if there's a lot of drought or high temperatures, cold temperatures, we get a lot of phone calls about that too. And then we also, like I said, we do those rainfall statements for the Hurricane Center, as well as provide service backup for the Hurricane Center and any of the advisories that happen when the wind is no longer a threat, and but it's still a rainfall threat when this tropical cyclone comes in into the United States as a depression. And lastly, but not leastly, it's actually growing in importance with time because the forecasting ability of the models continues to get better. The medium range forecast, where it's expanded from 72 hours to 204 hours, or day 3, day 3.5 to day 8. And again, very similar to the short range, we have 3 to 7 day fronts and pressures. There's actual other grids for temperatures, QPF, again, the precipitation, cloud cover, weather type. And then, of course, we're also coordinating with the Hurricane Center for their medium range forecast to make sure that what they want to have on their forecast is depicted well within our pressures and front map. And then we also have a hazards chart. Again, I box out this heavy rainfall. This is one of those event situations where we actually do these advisories for the inland depressions. So every once in a while, you'll see the Hurricane Center transfer its responsibility over to WPC. This is usually how most people know about WPC, because again, you're going from one of the more visible national centers of the Hurricane Center to one of the ones that doesn't have as sexy of a national weather hazard, as to coin a phrase. So let's go into some of those products. This is the surface analysis and fronts. You can see there's an example of the unified analysis, but down here in the corner, you can actually see where WPC's responsibility of analysis is. We take care of all of the CONUS with the exception of Florida, and anything north of 32. So you can see the National Hurricane Center is this area here, but anything north of 32 goes to the responsibility of WPC over land, or OPC, the weather or the Ocean Prediction Center, over the oceans. And then anything south of 32, but in the Pacific near Hawaii, is responsible for the forecast office of Hawaii, which, if you really think about it, is the biggest area of responsibility by any local forecast office. They're as big as a national center and have just as many roles that go on there. But what do we do for surface analysis? We take all those observations from across the United States. It comes into us through computer. But again, we have history of people doing it in the past by hand. And then eventually we start digitizing it. So this is done, this product is done, for WPC is done every 3 hours. at 0Z, 3Z, 6Z, 9Z, 12Z, so on and so forth. So every 3 hours. And Z time, just in case you are not aware, this is that universal coordinated time zone. So basically anything that's the same time as London. This keeps everybody coordinated and understood. So if you're not really familiar with Z time, which I'm sure most people are, that's what we generally run on, are these 0Z, 3Z, 6Z, time cycles. And then when we do this unified group where we're clipping together all of our analyses together, are only done at the synoptic times. And what we call synoptic times are 0Z, 6Z, 12Z, and 18Z. Basically the same times you would see any of the computer models being run. Though our analysis precedes those models because the models take that much time to run. So you'll see those on the web about the same time as maybe our surface analysis. So again, on that surface desk, we also do a lot of analysis with regards to record tracking, and we do a lot of things with respect to social media. So you can see many of these graphics that you see just linked here, you can find through our social media presence at Twitter, at Facebook. So please sign up for those. But we have a lot of record keepings now. We're not the National Center for Environmental Information, or the old name NCDC, the National Climatic Data Center, which is in Asheville. But we do have a lot of these older records that are kind of available to us, and we have a lot of people who are really interested in these kind of things. So Dave Roth is a forecaster who has collected all of the rainfall information with respect to hurricanes, and so you can go onto our webpage and find the records for your given state in which storm produced the heavy rainfall. You can find out what's actually the lowest pressures or the highest pressures on a given date or month. We also track the temperatures of like when we're going to be above normal or below normal, and you can also see where the forecasts are going to be departing from normal as well as maybe some localized rainfall totals and records. And then again, there's the high-low. So you can see all of these things are one of those ones where it's kind of an interesting piece, and where you can typically find these are on those social media presences. One of the things I really do want to highlight that we do in the short term are storm summary precipitation records. Now, if you're familiar with the local forecast office, they'll produce local storm reports or a public information statement. Well, that's very similar to what this is. And the storm summary for WPC is really taking all of those hazards that we generally deal with. So we talk about heavy rainfall, so the rainfall totals, high wind reports, high snowfall totals. We produce that and out of all that collection of all the local forecast offices and bring it into a totaled product that is this storm summary. And it's only produced for kind of significant storms. We don't do this for every single day, though there is a one of these links that you can go and see local storm reports every single day. This one is actually a text description of the storm, of what's actually going on, as well as a short-term forecast of what is expected to go on, along with all of these total records. And it's very important to note that CoCoRaHS observers like yourselves are very important to these reports. This is a lot of times where you actually see your own report show up on a national level scale. So it is quite important that you're actually producing quite accurate numbers in your but also doing it on a regular basis. It actually gets fed back to this, and a lot of times these storm summaries then go on to national media presence. So moving on to that second bubble, that short range forecasting, I'll show you a little bit of an example of things that are going on here, some of the products that we actually produce. So a lot of these are done through, so we're choosing computer models. One of the things I said before, the WPC has an expertise of looking at a tremendous amount of models. I mean, we have so many models that we have that there's a list and link of grid and all the meteorological fields that we have. And I mean, it's so daunting of a list of meteorology. We have analysis paralysis to coin that phrase, is that there is so much information and so many different computer models that are going on. But we have an expertise of seeing this every day, and we like to make these decisions on making large scale pattern determinations. So this is a product we like to call it the model diagnostics or the PMD-HMD. It's a product that discusses those model differences, and a lot of those model decisions go into help building which models we prefer so that the forecaster, even internally into the office, can start making new graphics. And so here's a description or another product suite, which is the pressures in fronts I described to you. So you can see here, this is what it would look like on the web page, where it shows different precipitation types, but also the pressures in the fronts of where they're going, as well as a daily discussion that's actually produced twice a day. Then you can see also here the QPF or the precipitation. You can see I've been throwing that term around, QPF. That is the Quantitative Precipitation Forecast. So, if you will, it's an encompassing term for forecasting the liquid value that falls from the sky in a forecasting sense. So it's not just the rain; it's also incorporating freezing rain, hail, snow, Graphical, any of the other meteors that are falling out of the sky that account for precipitation. And when we make those determinations of QPF, which we'll go into significant detail later, it drives this other product, which is the excessive rainfall outlook, which tells a person what is the potential for flooding or flash flooding. And again, those come with a discussion as well. And then the QPF also helps to drive the winter weather discussion. And I'd like to highlight again the talk that's going to be occurring in December. This is pretty complex, but taking this QPF and moving into the winter weather focus, WPC produces a lot of probabilistic forecast grids and products, as well as some internal graphics that go to coordination with local forecast offices and national centers. There's a lot of times we're doing phone calls if there's a particular hazard or there's a lot of model spread or uncertainty. The hazard needs to be described pretty well. We want to make sure that what we're doing for decision-wise matches up with the forecast offices as well as their input is fed into our decision, so that our decision can be fed into their products and warnings, so that everybody within the Weather Service is producing something quite similar or identical in all hope. Moving on from the short range, we've taken on medium range forecasting. So we're moving further away in time with the hazards, so we have similar products, but we also have fewer people actually working on those desks because we're producing the products in less than 6-hour time periods, as we were in those other ones where we're actually producing every 6 hours. Here in the medium range, we might produce every 24 hours or 12 hours, and then there's this thing called disaggregation, where we might take a trend, looking at some of the models, and they'll make a break of those things to produce 6-hourly bins of different things. But again, we're producing pressures and fronts, producing QPF. We're also producing max-min temperatures for grids, as well as those winter weather probabilities that are, again, being fed to the forecast offices across the country. Other grids that get produced are things like cloud cover or wind, even dew point and precipitation type. So those go and feed to the local forecast offices. They can look at them. Some forecast offices will actually take us verbatim and put the forecast in, especially if they're very busy in the short range or they have a hazard with warnings, things going on. So again, we're helping them by building this longer term product that if the things are too busy, you can leverage back off of this national scale prospect. And so again, the collaboration is more, it's actually less frequent and less specific in the short range, because obviously you have more uncertainty, and so you produce this. So these medium range folks don't get to chat with the forecast offices quite a bit, but again, those local forecast offices use a lot, and so because that focus is on that near-term hazard. And then during the Hurricane Center season, we also make sure we do that daily video collaboration with the National Hurricane Center, so that anything in the medium range with regard to the hurricanes coming up or showing up on these maps, we want to make sure we have that Hurricane Center depiction right, as well as providing our expertise with the models back to the Hurricane Center, because maybe they're looking specifically at the hurricane, but sometimes we can see things at a larger scale of maybe how a larger synoptic system is coming in. But of course, they have a tremendous amount of experience too. So, you know, that's a pretty easy collaboration that occurs daily during hurricane season. So one of the last products I really like to highlight, and this is actually one of our most popular products. It's one of the most viewed products, particularly here in the short range. This is that encapsulation of all the different hazards that are actually going on. And this is the graphical hazards depiction that's produced. And it typically goes to FEMA as well as other emergency managers immediately each morning to see the different hazards. And I chose the day that has all of the different hatched areas that are going on here. So in general, the things that are not hatched are just general precipitation. So you can expect all of the white areas, snow. The green area is rain. This green area with little dots is actually thunderstorms. And then this blue area is a mix of potential of rain and snow. So it can give you a broad idea of what's going on. But again, the hazards that are mostly highlighted here are heavy snow potential here in this hatched white. You can see the freezing rain potential that's in here in this hatched purple area. Then you have heavy rainfall or what's driven by the ERO. Anywhere that there's slight risk or greater is done in red, and anywhere where the Storm Prediction Center has severe weather is in yellow. And just recently, we actually added the SPC critical fire weather. So I'm going to switch over here. This is just a good example. We just recently did this almost 3 weeks ago, so you can see that this little gray hatched area is that area of increased fire danger. So places where they might have red flag warnings up or so on and so forth. And this product was actually started back in 2001, and it's only produced for the continental United States. So we had been producing this for such a long period of time, but we noticed that we have a lot of issues that we need to talk about even further into the future. So how do we expand all of this into the day 3 to 8? Originally, the Climate Prediction Center was producing the medium range, what we call medium range, or day 3 to 8, and they were doing the long term, which they would consider like 8 to 10 or even 2-week or even monthly or seasonal scale. They transferred the responsibility, considering how we have all of our medium range products, to WPC back in 2019. This one actually includes Alaska, given the fact that we have a responsibility of doing medium range forecasting and model decisions for Alaska. You know, that has hazards, so things like high winds and high wind waves show up occasionally in here as well. But heavy rainfall areas, or in this case, you know, much below temperatures, because this is the actual first one that we ever produced back on February 25th of 2019. And again, this one, unlike the day 1 through 3, actually has a discussion that can be checked out. So you can again check on this link as well. So with discussion of all these products, all these goodies, where can I get them? And the simple answer is the Weather Prediction Center's webpage. And then again, it is a very big, broad in scope webpage, and it can be a little daunting to navigate too. I understand that. I mean, I've been working for WPC since 2015, and I've actually worked close by WPC in the satellite analysis branch as early as 2002. And so even to this day, I happen to go perusing through some of the other links and tools, and there's just some new goodies that you find on this page. So always come back and check out what's going on. But at first, I mean, what you can see here is that I want to highlight this area in red, which is kind of the crux of our biggest hazards that we deal with within WPC. So the excessive rainfall, the heavy snowfall, and the potential for ice. And so given different risk categories that are going on, so you can quickly click on any of these and it will take you to those products discussing any of those threats. So again, heavy snowfall potential being possibility being high, greater than 4 inches, or ice greater than 1/4 inch will be highlighted here, as well as a link to any of the medium range hazard discussions. On the right-hand side, you'll see that there's a top stories box. This includes things like ongoing mesoscale precipitation discussions, so things that are really important things that are highlighted and are kind of rapidly evolving, such as the MPD, as well as upgrades in the excessive rainfall. Typically, when we move from a slight risk to a moderate risk or a moderate risk to a high risk, you can see that those products will become highlighted in these top stories. The storm summaries will be over here. Any of the times we're talking about those storm summaries where you see all the CoCoRaHS observations, they'll be over here. But then if there's nothing really going on, as this is the case that's going on here, there'll be kind of more like key message slides or seasonal highlight slides that can kind of illuminate your ideas of what you may need to know from WPC's products to give you a better understanding of what's going on. Now, this main box over here on the left is where you're going to see the products. And anytime you can click any of these tabs in, it will change the box below here. This is just the example of that overview, that the most popular product of that hazards analysis. And if you want to read the discussion, you can actually come down here to the bottom, and there'll be a little plus box, and there'll be a discussion that goes on here. But you can click on any of the surface analysis and QPF and excessive rainfall weather that's going on. You can also choose the drop-down tab for all the products or discussions. That shows up here on that forecast and analysis one. And then there's all of these other drop-down tabs, as well as this forecast tool, or all those little goodies that you need to do, and then things you can find out about us. So I know that was not much of a quick overview into WPC's products, but I would like to move on to kind of move the real focus and meat of this product. And we are halfway through the slides, but I really want to touch base on this. This is kind of the real crux of those things. But please do check out the webpage for more information, or go back with this recorded discussion and check out those links that we have before. So rainfall extremes are a gigantic issue, and so this is a briefing that was produced by the UN a while back that talks about the human cost of weather-related disasters from 1995 through 2015. And even though hurricanes get a big pay attention, or tornadoes or anything like that, you can see here flooding and even droughts are the most impactful disasters when it comes to the weather, when it comes to life and property costs, with fires and things like that, and other heat-related deaths occurring later on at a little lower scope. And this slide here is actually one of my favorites, and so that discussion you saw there with all those hazards, that was from 1995 through 2015. This is the first year after 2015 for the fiscal year of 2016. So that'll be October through October. But I really like this slide because it really hits the point of that overlooked nature of the significance of heavy rainfall to that cost of life and economic fold. And a lot of times when people think of heavy rainfalls, they think about tropical cyclones. And if you actually look at these 6 particular cases, there's only 2 that actually show tropical characteristics. None of these are actually landfalling tropical cyclones. The one here in the bottom left corner is the synoptic or larger scale heavy rainfall due to the tropical cyclone Joaquin. So the hurricane never came close to the coast, but the moisture got pulled back to South Carolina. And then lastly is an inland tropical cyclone-like system that occurred in Louisiana, produced 20-30 inches of rain. So it didn't even develop into a depression, but it obviously had significant problems. But again, you're talking about December, so heavy rainfall can occur at any given time of the year. But again, this is $17.5 billion in losses, with effectively 125 fatalities in just these 6 events alone. For this year alone. And that's why it's so important. And most of these fatalities actually occur in cars. People think that they can cross, and that's just not the case. And so just to give you some spec, I'm sure you saw this, but anything that's in yellow is greater than 15 inches. And the oranges you see here are 8 to 10. So that's a huge area of oranges that you see there. So again, WPC has 60 years of legacy QPF forecasting, and with over 30 years of experience doing this excessive rainfall, or what the probabilistic threat of heavy rainfall is going to occur. And so now I want to kind of get into the meaty portion of probably the meatiest slide of what's going on here. So a lot of questions probably are like, how is the QPF forecast made? Here's an example of a short-term forecast. This is just in 24 hours. This is what we would consider a good model suite of model spread of 24-hour inch rainfall. These are different models that you can actually see. So again, going back to what I talked about earlier, there are two desks that do QPF as well as ERO. There's the day one or short-term desk, as well as the day 2 and 3 forecast desk. And there's also that day 4 through 7 forecast. And what we do is we're producing an aerial averaged 5-kilometer grid that it's actually downscaled to 2 kilometers. So we take things like topography into account. There are different ways to do that digitally behind the scene, but this is a human-generated forecast. So we're actually analyzing the environmental parameters such as temperature, moisture, winds, and instability, taking all of those pieces into looking at what the computer model actually tells us, knowing what the computer model skill or bias might be, knowing where the uncertainties might occur. And then synthesizing all of those in together to a blend of those best models, where we can increase or even decrease precipitation models based on those environmental parameters that we see, based on observations, based on knowing that the example of where we use some of these global models like the GFS, which is the United States model, or the European model, or the United Kingdom model, the Canadian model. They're different models that come together, as well as their ensembles, which are like small tweaks that occur with the initial conditions that give us an envelope of potential solutions. And we're taking all of that and putting those together to make that best blend. And again, the QPF is for all types of precipitation. It's not just how much rain is going to fall. It's going to be snow, sleet, freezing rain. Where WPC produces these in 6-hour increments, 2 times a day. What's interesting is actually during that 2-time cycle, we produce an initial forecast that basically runs directly after the GFS is available to us, the new GFS. We then disseminate that. We go to the forecast offices and collaborate with them. And then when new models are coming in, we're also assessing those. And then we produce a final product. So in a sense, we're actually producing this 4 times a day, but really we have 2 9-hour shifts that are focused on this. And again, those products, once we do it in the 6-hour increments, are produced in a 24, 48, and anything up to the 7-day graphic totals. Now, that's just specific for day 1 and day 2, 3. Now, days 4 through 7, there is that forecast of 24-hour QPF. It's just done in 24 hours, and then it's disaggregated into those 6-hour bins. But again, combine all those together, and you can see some of those really great graphics that show up with the 7-day expected totals. And again, those totals are a deterministic or specific exact value. So those are going to change. Deterministic forecasting is quite important. That's what people want to know. It's going to rain this much. It's going to be this much snow. But what are the possibilities? And that's the probabilistic. And that's actually where the Weather Service and the weather enterprise as a whole is really kind of going towards, is that what is that range of possibilities? And in that sense, when taking all of this into account, what is this going to do for the hazard? And that's what actually drives the generation of the excessive rainfall outlook. And we call it the excessive rainfall outlook. Some people will look at it as what's a flash flooding, but excessive means, it's really going to exceed the local conditions, where we expect local conditions of hydrology could be exceeded, this thing called flash flood guidance. And we'll talk about that when I talk a little bit more about the ERO. And then additionally, this QPF is then sent to the winter weather forecaster. And I again please see the December talk about how the snowfall and freezing rain products are produced along with their probabilities. So taking all of this and taking all these pieces of information, going into our graphic editor, we can actually come up with a 24-hour forecast. So you can see all that range, and this is actually the final product that WPC produced. And this was just 2 days ago when we had the heavy rainfall across Oklahoma into Texas and Louisiana. So precipitation expertise, how are we doing with this? I mean, really, what are we doing? So this is the way that we do this is like is that we verify ourselves against a statistical nightmare, which is called an equitable threat score. You want to get the shape, you want to get the size and the area of a particular object, and this equitable threat score is the best method statistically. There are statistics textbooks that talk about this particular statistical method, and they use rainfall as the example, because what this does is it'll take what is the area of 1 inch and how well did you make it shape, how well did you do this. And so the value that's over here is on a 0 to 1 score, where 0 is like a random shot and a 1 is a perfect score. But let's be honest, you know, QPF is extremely random and chaotic, as you could probably guess, and it's very difficult to get all these precise little things right. So actually scores that are down here in the tenths are okay. You get up to a quarter, that's actually pretty good. You get up to 4.4, that's actually quite extremely good. I mean, that's impressive. And then of course you have a bias of like, did you make it too big? Did you make it too small? And how much of a percentage of the area does that cover? You can see, actually, this actually shows you a trend of the 1 inch area. But this is how we are graded in WPC, is this 1 inch area at our forecast time periods of 1, 2, and 3. It's just a proxy of how to deal with heavy rainfall. And you can see as the trend increases, is that we're actually doing much better. And actually here, if you go to our day 3 forecast, this is quite impressive, is that if you go back at 2019, it goes back to the day 1 forecast back here in about 2000. So we're making significant strides forward. And of course, that is, you know, driven by the computer models. But computer models themselves aren't just, you know, perfect alone. You do still need a human in that aspect. And you can see this is the example of taking this in the day 1, taking these statistics over here, looking at it and comparing that threat score that I talked about and how well WPC is doing against these other models and what's their percentages. In the examples here, the green here is the North American model, also known as the NAM, which is a short-term day 1 to 3 forecast model. The GFS is the US model, it's the green here. And then you have the magenta here is the European model. So those are the ones that people are generally most familiar with. And you can see here that in the winter, precipitation is very good, but the precipitation is still really hard in the summertime. You can see that the WPC forecaster provides actually more service with that convective aspect, because the computer models continue to get better with the winter style in terms of the broader, lighter precipitation totals. But you can definitely see that we're definitely making an improvement. None of the scores are actually below. And so the man in the loop, if you will, is still doing that. But you can see, although down here, these other 2 lines, which are an ensemble bias corrected method, there's statistical models that are trained of maybe a neural network computer that are trained against different statistical methods to come up with the best idea of combining all those models I showed you into a common blend or a common starting point. You can see that this common starting point is actually quite good. You can see the numbers here. WPC is still not doing, it's still improving on the models, but that percentage is significantly reducing. But you can see that this multi-model approach significantly reduces the errors, if you will, in the longer term, or in the summertime when you have convection or when individual models are not doing particularly well. So let's see an actual real-world example of how WPC's 5-day forecast went on. It's like, so forecasting at 25 to 30 inches is incredibly difficult. But without these computer models, we wouldn't even dare tempt this feat. But you can see this is the example of Hurricane Florence when it made landfall in 2018. No one would even dare forecast 25 inches of rainfall in a particular area. As you can see, this is actually quite good, where the 3 to 4 inches, 5 to 7, and you compare it even here to reality. Now, obviously, there's still plenty of places that need to be fixed. Obviously, here there's an overestimation by WPC. seeing specific tighter bands in here. I mean, we haven't gotten to that scale yet, but we've converted to get to be even finer scaled here, just even since we've done those forecasts. But to forecast something as high as 36 inches of rainfall, and I mean, we're talking about making a forecast of 30 to 35. This is quite incredible. And you saw probably in Harvey the same thing. We made forecasts to greater than 50 inches, and of course that's when it fell 60 plus inches. But you can see here the importance again of the CoCoRaHS observer. The radar actually went down here in Wilmington. I like to focus on this because there was a CoCoRaHS observer that actually measured here. So that value, if you look at this gridded forecast, is actually less than what actually fell here. So those reports are critically important. Again, that was a state record for North Carolina, and without you there, it would never have been known. And with the radar going down, some of these values were underestimated. So again, looking at how that forecast was made, or at least one portion of that forecast. Here's the day 3 forecast where it's a little bit north. Day 2, we're starting to shift a little bit south. And day 3, we're starting to see some of these banded features that actually come to fruition. So this is really good. So just to give you an actual real life example. But again, the computer is getting much better. So WPC's focus is actually shifting towards decision support services. So that uncertainty, that probability, and how to communicate that probability. So what we have is very similar to maybe some people are familiar with the Storm Prediction Center. We have the excessive rainfall, where we want to go from outlooks to watches to warnings, and then the event occurs. Where does WPC fit in? Well, we're obviously doing the outlooks with the ERO. But our goal is actually to extend this past day 3, and it's actually a really short-term growth level. We'll probably start to see really soon. But then we also have this gap, or filling in the gap kind of situation from when the watch occurs to actual observations, but yet still a short-term forecast. And that's where my desk, the Met Watch, or the Mesoscale Precipitation desk fits in. We really want to put this in here. So again, that shift in hazard and effects. But what is the excessive rainfall outlook itself? Taking the deterministic rainfall forecasts are imperfect, and completing the knowledge of those hydrologic conditions that are underlaying it, will cause some issues, and we know that's going to be limited. These excessive rainfalls convey that risk of flash flooding using probabilities and tying that to risk messaging. So it's similar to those convective outlooks that you see at the Storm Prediction Centers, and why the difference is, and you'll see, it's like, well, that looks very much like the Storm Prediction Center. But a great way to tell the difference, one, we don't have the enhanced area. That's a really great way to tell which one's ours. The other one is that we have curved lines. So we're using the same colors because we want to have people who are familiar with the convective outlooks to be familiar with some of the things, because of many of the same things that occur with the Storm Prediction Center we have here with WPC and the excessive. So, but one of the things that's confusing is, as you see, what's the percentage of possibility of what's going on here. So when you see a high risk, it means that there's a risk that is 50% or greater than exceeding flash flood guidance within a 25-mile area of anyone in that particular circle. So if you're in here and you have a high risk, someone in here has a 50% chance of exceeding flash flooding. It is not 50% of that area will receive flash flooding. So that's quite important to know. But if we take the example of this high risk, that means that one person within the entire 3 highway rings, so you got the inner ring, the outer ring, as well as the higher ring, will experience it. But we can infer some things from being in proximity too.
Greg, just to let you know, we've reached the top of the hour.
Oh goodness.
We still have time though. We're still good. I just wanted to let you know what time it was.
Yeah, I appreciate it, Henry. So this chart actually can describe a little bit better. This is actually trying to understand the excessive rainfall areas. So again, that 50% for the high risk, 20 to 50%, 10 to 20%, And then 5 to 10% are in these marginal areas. With anything outside, could still have flash flooding, but the probability is less than 5%. Now, that this does not explicitly forecast impacts, but it can allude to those prospects of significant impacts, are more likely when this extreme rainfall does occur. It's more widespread. So you can also make an assumption that you're going to have a higher chance of this rainfall overlapping the underlying vulnerability areas. So as I stated before, it is not a percentage of coverage, but you can infer that as you're closer to other reports with a higher probability, that there is going to be a higher probability due to your proximity. And again, WPC is actually, there's plenty of research to show that we're actually quite well collaborated with those percentages. I didn't have time to show you those slides, but this chart is actually also available in Spanish too, if you know anyone that needs it in Spanish. So how do we characterize the high-risk days? Why is this so important? Because high-risk days are a strong indicator of the deadly and damaging flash flood day. 51% of high-risk days have at least one fatality that occur in them, while this is compared to only 23% of moderate. Yet 68% have at least $1 million in damages. That's a significant amount compared to 34%. So high-risk days are incredibly important, though are also incredibly rare. So high risks are only issued about 4% of the days, and account for about two out of every 5 of the flash flood or flood-related fatalities in the United States. This is from a study from 2010 to 2018, but do also account for 9 to 10 of the damages. So high risk is a big deal. So going on to the ERO, and how is this actually important to your local area? As Henry pointed out, there's so many people from different locations. What is the probability of a particular day seeing a high risk? So taking a look at everything through 2019, you can see these are all the places that high risks were located, with some areas, particularly Houston, at high risk. And a lot of times this was with hurricanes, but again, not always hurricanes. Just even yesterday or 2 days ago, we had that heavy rainfall come through Houston, again, even though a lot of the models were further north. When are we going to see these seasonally? December, January, and February, we see them actually coming off the Gulf Coast, typically early in the morning, because that's where the source of moisture is, or out here on the West Coast. Then you start moving into convective season. You see the severe weather. So this moves very well with the severe thunderstorm threat. But again, it's not directly tied to it. It does lag a little bit. And actually, with stronger thunderstorms, you actually have more dry air in the mid levels, stronger updrafts. They're actually less conducive for heavy rainfall. Heavy rainfall comes typically with areas where you have less dry air aloft. And so, as you get into late season, when the depth of that moisture is here, you can see how the slight risk expands and lifts north. So Kansas City all of a sudden becomes a big threat. Then you still have areas like West Virginia, which are actually prone mainly because of the fact that you have complex terrain. But you can also see out here in the West, when the monsoon starts showing up, we see a lot of monsoon issues. And then we start to get into the calmer seasons where we're getting just reduced threat as everything starts to shift back south. So I'm going to talk real quick about the mesoscale precipitation discussion. Again, it's that gap fill, and it's a technical description of the near-term environment to forecast the flooding conditions with the emphasis on those rapid rise or flash flooding. Because some places don't technically flash flood, where you have fast moving water, but you have somewhere like Florida or Houston where the water just inundates and rises really fast. And that's what we mean by flash flooding in a true-on sense, is that rapid rise. And that these will help really short-term messaging for local forecast offices with preparing for flash flood warnings. They come with these graphics, so just showing 2 examples where we can put satellite imagery underneath. And then you can get those on the webpage, or you can get an automatic Twitter as well if you follow us on Twitter. And it, again, fills that information gap between the ERO, which is issued regularly, and the warning itself. Typically, they run from, are issued, and they run for, have a valid time from 2 to 6 hours. But our goal is to be 1 to 3 hours prior to that flooding onset. The categories are possible, likely, and rainfalls, heavy rainfall. So heavy rainfall describes, we think it's going to be heavy rainfall, but maybe not flash flooding. Then we have possible, which means, yeah, flash flooding is possible, but either confidence isn't very high, or the magnitudes aren't very high, or the aerial extent isn't very high. And then we have the last category of likely, where we're pretty confident flash flooding is either ongoing or will be expected to ongo, probably with some significance. And then this also goes back to how this all familiarized is that Storm Prediction Center produced these products in the past. So prior to 2013, when this product moved over to WPC's responsibility, SPC was responsible for it. But with all of their other things going on, and concurrently, the tornado and the hail threat just dominated the precipitations, and the resources weren't that high. So with WPC's expertise in precipitation, it was an obvious logical step to move over to WPC. And so we did start issuing those April 10th of 2013. They're generally the size of half the size of Kansas, or multiple FOs. We don't want to be in a local forecast office backyard about flash flooding. So we tend to let them manage their own thing. We want to talk more about a mesoscale, or a larger scale. So you go from a local scale to what we call a mesoscale, or medium scale, to a synoptic scale. But the mesoscale in the middle is, we want to talk about the elements that are locally going to produce the heavy rainfall. And again, this is very unique to WPC's schedule-based routine. Everything in WPC prior to this product was very regimented in terms of when it's produced. It's produced on a regular basis at a given time and any given day. Forgive me, I'll pass through these statistic slides of when you expect them. Well, of course, you're going to expect the bulk of them occur in the evening and the overnight when thunderstorms are occurring. But if anyone can see when we have a shift change, that's one pretty easy to see. And then when during the year do we have them? You can see the bulk occur between April 15th and October 15th. This is generally when we're producing on average 2 per year, or excuse me, 2 per day. But July 22nd is our peak, when we're on average producing over 8 of these discussions per day. So it gets really busy, and this is one individual at a given time, with maybe a secondary person overlapping when the shifts provide. But you can see the record that we produced so far is only 1,078 versus the Storm Prediction Center, which issued much shorter discussions that lasted a little shorter. So they have about 2 to 3 times more than we do. But the last thing is what's this blip here at the end of December? What's going on here? Why are we downtrending and suddenly December increases? Well, that's a special kind of mesoscale precipitation discussion that we deal with atmospheric rivers. So it's a surge of tropical or subtropical moisture. Sometimes people used to call it as the Pineapple Express. Typically leads to prolonged light to moderate rainfall days. So you're getting accumulations of 5, 10 inches, but over a week and a half. They're enhanced by coastal topography. And what's interesting is that in this area, we don't have that tool that we call flash flood guidance, which is how much rain is going to fall in a given area that will actually lead to flooding. They don't produce it out there because they have a thing called that we don't experience flash flooding out here. Well, that's true and not true, in my opinion. They actually do experience flash flooding, but it happens so regularly because of these atmospheric rivers in the winter that you don't have people living in the areas that are threatened. They built the infrastructure out of those areas because it happens so frequently. And so if I go back to that graphic here, you can see that why are we so reduced is back in 2016 is when we started doing this, September 2016. If you take that 2016 numbers and start moving up here, that's where we are right now. And this was just time that we were actually just trying to learn where we met. We're just getting experience ourselves of what were the conditions to really lead to flash flooding. And I think we've really come into our own here in the last 4 years. So again, atmospheric river ones can produce flash flooding in our sense. That rates can get up to 3/4 of an inch to an inch an hour. So sometimes we will label that as flash flooding possible, but it's a rare case. But as you get further south into California, it is more likely because you have things like burn scars. And actually, southern and central California mountains are less frequent with these atmospheric rivers compared to the Cascades, and everybody's experience and knowledge of Western Washington constantly being rainy. So what are the challenges? I've shown you all these products and how they're produced, but what are the challenges in the future? And I allude to this with the mean precipitation graph, and that's just an average based on the combination of radar as well as of observations of the mean precipitation in the last 50 years. So this is what 2019 looked like. You can see here, Washington, it had the highest, as you would expect, at 178, but a large area of places that have greater than 60 inches of rain. 60 inches of rain here is this transition from this orange to everything. And each one of these white circles is that state local maximum. So again, this is recorded. Please come back, take a look at this to see how it all matches up to what you're going on. And the lowest value here is North Dakota with 39. So every state had a place, minus North Dakota, over 40 inches in estimated, or well, not estimated, it's the radar combined with the observations. So it's not exactly perfect, but it's as close as we possibly can without those fine precision. But again, we get CoCoRaHS that helps to add into this. So this is actually its departure from normal. So I showed you Washington there at still the highest value, but having about 179 inches, but it was over 15 inches below normal. That really kind of shows you, sometimes you can't look at just this particular annual total precipitation and make an assumption, because North Dakota was over 15 inches above. So you can see the areas that were going on. And some people say, well, we're seeing all this extra precipitation. What's going on here? It's interesting. North Dakota, South Dakota, Minnesota, Wisconsin, and Michigan all had their wettest years, according to NCEI, or the National Climate Data Center. And Washington had their 9th driest. But overall, Washington was the only state that wasn't below normal for precipitation. And so I want to go back to that 2015 UN graphic and show how does this rank since we've seen that in the United States. And based on the 10-inch ISO height, we can say areas that are basically running above normal. How big that area is, can we do a one-to-one comparison versus the long-term mean? You can see 2016, where I showed you all those different heavy rainfall events, ranked 7th on that list. 2015 is 1st, 2018 is 2nd. I mean, the entire East Coast, I mean, here in Maryland, we had over 80 inches. 2017, 2019, all of these are top, are 4 out of 5 or top 5, and 2016 is 7th. And you can even say, it's like, okay, well, let's compare it against the 4th ranked, which was 1983, which was mostly out here in the West in California. And you can see what this is above the area. So in 2015, you can see there's a really big area of well above precipitation. But then here in 2016, you can't say, well, there's not a lot of areas that had above normal, but you can say the whole country was generally above normal. So these are just anomaly charts. So these are challenges that we're going to deal with that we see. So we've definitely seen a significant increase here in the last 5 years. Another significant challenge is trying to describe scale. So hitting back on Harvey and Imelda, 2 tropical cyclones, recent memory of what's going on here. It's like the areas that show the 20-inch contour. This is a contour of 20 inches or greater. I mean, this is huge, but both are tropical cyclones. Both sat around for quite a few days, but Harvey was so much bigger. But how do we describe that? And those are some of our challenges. And to me, this is probably one of our greatest challenges. This is the bullseye effect, as coined by Ashley and Strader, and how it's expanding. This is just an example of the percentage of impervious surface. So basically concrete, which is going to lead to greater runoff between 1950 and 2019. So you can see, simply put, that these developed areas are expanding and widening in areas with those impervious surfaces. So even with no trend of extreme rainfall, this would be a prolific risk for flash flooding and extreme rainfall, because all those impervious surfaces none of it soaks in and the majority runs off. And so random training bands of thunderstorms, just even for a few hours in just out here, like we had just the other day, led to flash flooding just southwest of Houston, that in the past would not have led to that. So you can see, even areas that maybe you lived in for 30 years, the development might have been successful to deal with that runoff in the past, but may not respond the same in the future. So, I just showed you that graphic of Henry and Imelda, just 2 years of difference. And there were places that said, I dealt with Harvey, and I was in a very similar area that had over 40 inches. And Imelda was worse. Is it because of the fact that Harvey changed its environment? Was there more impervious surfaces? So there's a lot of human or man-made factors that do drive towards these flooding concerns in the future. So we are seeing an upward tick of flash flooding concerns, even without an increase of moisture available in the atmosphere, and though we do see an upward trend in it, you have just the impervious nature of it anyway. So there's your main man-made factor of concerns. So with that, I appreciate you just sticking with me for a long conversation. I know that this was my quick view was not so quick, and my deeper dive was also not so quick. So I greatly appreciate you sticking around, and I'll leave it up to any questions. I do have some extra graphics if some of those questions do come up that I can allude to. So thank you so much.
Great, Greg. Thank you so much. This is a wonderful presentation. We really appreciate you taking your time today to give it. We're going to take some questions. I know we're running a little long here, so we'll probably go 10 or 15 minutes. If you want to type in your question right at this point, Greg will try to answer it. If he isn't able to at this time, he will follow up with you via email. And so type in your name and your state as well as you do that. And again, I want to apologize to a lot of people who signed up for this webinar. We had some technical difficulties with our provider, their GoToMeeting or GoToWebinar, and a lot of folks were not able to get in today, even though it was promised that they would. Just the times we're in right now. So we're going to send out a message. You're probably watching this later on already, but we're going to record this. We'll have this up and hopefully on our screen today a little later, and we'll send that a message out to those who registered and were not able to get in on this. And again, I've had some working from home. We all are, or a lot of us are right now. So I had some technical difficulties myself, and did miss a few parts of the webinar. So if you ask a question and Greg has already answered it, I may seem foolish in not knowing what that was, but we'll pass it on to him. So at this point, a question that comes up we hear now and then, and we'll just throw that out there to you. I know with winter storms, a lot of times they've been naming those lately. So, but hurricanes have names, but again, different media outlets have named the winter storms. What's your take on this? Why is that not something that the Weather Prediction Center does?
Yeah, I mean, our focus is moving towards winter weather and things like that. And so names with this, it's interesting to me is that the reason why tropical cyclones were named in the past really has nothing to do with even notifying people. It actually has to do with making a reference to it in an area, the ocean, that has no geographical references. So one, okay, this is the storm that's moving from Texas to, New York. Now you're describing an area. And a lot of times those names actually were better, and in my opinion, were better memorable by something that occurred with it, such as the Knickerbocker storm when you had the collapse of the building. So naming it prior to it occurring can lead to some confusion. And additional to it is that, there are multiple pieces. Like a hurricane, you see, the low-level surface circulation and the upper-level anticyclone are basically one and the same. They're both in the same places. With a a non-tropical cyclone. There are many little pieces, and the surface cyclone might be developed by one initial upper level feature, but then reinforced by a second one. So it leads to confusion of when to start a name and when to end a name. And so we have our storm summaries that we list out there, and in our winter storms, we don't have a name. We list where it's going and where it's been kind of thing, and what the hazard that goes with it. And I think that's always been a really good thing. And the director of the Weather Service, Louis Uccellini, is a big proponent of not doing that because of similar reasons.
Thanks. Okay, here we got a couple questions coming. Here's Frank from Connecticut wants to know, are most commercial weather forecasts based on the WPC?
Are most of them based on the WPC? That's a hard question to ask. We make everything available, but again, we don't know exactly who comes in and takes our grids, because those grids are produced, they're disseminated. People can download them, or they can look on the web page and see them. So indirectly, I'm sure, but it's almost impossible to delineate if it's exactly the same as any of those. And more than likely, they have their own responsibilities and local things that they do. It's kind of similar to how the Weather Service Forecast Office is going to do too, is that they don't directly take our forecast and go 100%, they will make adjustments. And again, the local forecast is your forecast for your local area. So there could be slight differences. But for the most part, I would always go with your local forecast office with the exact numbers. But that's also one of the reasons why we have a larger domain with our QPF. Again, our goal is to aid them. Now, if you can infer stuff from it, great. If other groups can infer stuff from it, great. But knowing precisely who's using it, unfortunately, we don't know exactly to the exact number.
Henry, if you're asking a question, you're cutting out. I'm not hearing you.
Oh, no. All the bandwidth across the United States being used currently, that's probably the main.
Right. So this is NOAA, and I will go ahead and ask the next question. So Ken,
come back. No.
Oh, never mind. Go ahead, Henry. Thanks.
No, that's fine. No, go ahead.
Okay.
Why not try out?
I'll ask. Ken from Virginia is asking, he says, I see large differences in current information versus actual information. By that, I mean my local temp was 4 degrees below what the current temp map showed. So why would that be, that what I'm getting is different than what the current map is showing?
I'm perhaps a little confused exactly what he's asking. If like the maximum temperature that's forecasted is different than the current forecast or the current observation. I mean, a maximum temperature could be off. You could, or if you're meaning, say, like your app says that it's the forecast is this current hour is let's say 57, and the observation that you see at your house in the app says 54. One of the things could be is just the fact that the observation that they have there is actually at a different location. I see this quite a bit. Like, for example, for me, I live very close to Annapolis, Maryland, and the default temperature is actually on the ocean. It's right there at the Naval Academy. And so the temperature actually at my house is 4 or 5 degrees difference. So that could potentially explain some of that. I hope I got the gist of your question.
Thanks, yes. And Henry, go ahead and take over from here.
Yeah, no, sure. So Jim from Illinois was wondering he's curious what kind of computer models, excuse me, computers produce these models that you base a lot of the stuff from.
So that EMC, the one of the national centers talking about it, the Environmental Modeling Center, they're responsible for numerous supercomputers. And what I mean by supercomputers is maybe you're familiar with Watson from IBM. It's not as high a level as Watson, but it's just that little step behind, if you will, the newest, greatest computer. The weather computing models can do quadrillions of calculations in infinite, really quick seconds. So, I mean, when I was telling you about those high-res models, I mean, you're taking the entire domain of the United States and you're talking about grids that are below 5 kilometers, and some models are even below 3 kilometers now. The larger ones that do the entire United States, like the GFS and the Euro, they're out at 25 kilometers. So all those computing and computations are going on. Those supercomputers are, you know, the top level ones. I'm not particularly familiar deep down with all of the infrastructure of that, but again, that's an EMC question. But they do have some super powerful computers. I mean, just the top level ones. In fact, I think they just recently replaced or just got a new contract for their most recent ones that I think is coming online in either the next few months. So you'll have to double check on someone who's much more knowledgeable than me, but they're always at the top level.
Okay, here's one from William in Northwest Florida, and he's wondering, what is your definition of torrential rainfall rates? So he's curious about what that definition is.
That is the greatest question that you could have from a communication standpoint, because a torrential rainfall for one location, such as in Northeast Florida, is a different thing than a burn scar out in California. A burn scar in California can only take, if you will, a quarter inch of precipitation an hour, and you're getting mudslides. But you down in northern Florida, I mean, you just had an event just a couple days ago. You were receiving 4-5 inches of rain in 3 hours. So that goes back to that flash flood guidance value that you were talking about. It's like, what is a torrential? That's the thing that sets it. And generally, when you get to the coast, it's about 4 or 5 inches an hour. And again, that also depends on what has occurred during the winter. What are the ground conditions at? Because a wet soil is not going to hold as much, and so more of it's going to run off. An urban center is going to have more runoff. So generally, we like to say 2 inches per hour will lead to flash flooding or rapid rise inundation or greater. But the thing is that in reality, if you get that down into 15-minute ranges, that's probably closer to 4 or 5 inch per hour rates, but it only lasts for so long. So that's one of these really hard things to communicate, especially when you're talking about, you know, flooding. And flooding itself is difficult because there's so many different permutations of that as well. What's the difference between flash flooding, inundation flooding, urban flooding? And so there's a project within the Weather Service as a whole to try to simplify this called hazard simplification. It's trying to get all of this so we can get one product with different gradations of that explanation in there, so that we can handle that kind of situation. But WPC's excessive generally deals with that rainfall rate, not it's rained, you know, 4 or 5 inches over the last 5 days, and so the Ohio River or the Mississippi River is flooding. That's actually with a focus called the River Forecast Centers. And that's longer term or main stem flooding. That is going to be kind of managed, if you will, by the National Water Center, which is in Tuscaloosa, Alabama.
Okay, so we've got time for one last question here, and then Greg will follow up with you. We have a couple other questions that came in, but for the program today, we're going to end it with this one. And Jim in Florida, and again, I think I was cut off earlier when I was asking this one. Are there phone apps out there that are available for getting weather notifications of the heavy precipitation?
So from the Weather Service perspective, the National Weather Service is not actually in working with the private sector. The private sector is technically responsible for a lot of the weather apps. A lot of the forecast apps and things to that effect. The National Weather Service technically can't compete against that with an app, but you can receive those flash flood warning alerts. The tornado warning alerts and flash flood warning alerts can alarm directly to your phone. You know, if your location, or actually your cell phone tower, is within that hazard box.
All right, well, we'll end it there for today. Thank you, Greg, so much for taking time here to give us this great overview. And then we'll have in December the other half of this from Josh Weiss. Will be talking about the winter weather stuff. So you'll want to come back for that. And again, we're recording this So you'll be able to do that. And Greg is going to send us his slides. So if you'd like to go through slide by slide to take a little bit of time, that'll be on our website as well under our CoCoRaHS Weather Talk got a mouthful there. Weather Talk Webinar Series tab on the right-hand side. You click on that. You go to the bottom. You'll see a list of this and other webinars that we've had in the past, and then you can get all that information and actually watch this one over again. Well, again, Greg, it's a pleasure having you with us today. And we're going to, as we close out our program, we want to let you know that we have another CoCoRaHS Weather Talk webinar coming up, and that'll be on June 4th. So just about a month from now, you won't want to miss it. So Chris Vagasi with Vizsla is going to talk about lightning and lightning detection, and that should be an exciting one. I'm looking forward to that one as well. Before I forget, when signing off today, please take our survey that'll pop up on your screen. And until we meet again, stay safe and stay healthy. This is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and have a great afternoon.